Bismillah ar-Rahman ar-Rahim. Today, inshallah, we will have a very important lecture. As you may remember, before, when we evaluate the project with an initial investment equal 170 and a cash flow equal 10, 25, 380, we have an assumption that this cash flow has no risk, which means we are 100% that year 1 we will generate 10, year 2 25, year 3 25, year 4 380. But in reality, this is not right. Each project, it has a different risk, and the risk we mean by risk that it has a volatility في تقلب في الكاش flow. So now how can we evaluate the project under risk condition? We have two types of approaches we can use it to evaluate the project under risk. First one, we call it risk adjusted discount rate. Second one, certainty equivalent method. Okay, to understand the idea, remember this is the NPV, net present value, equal what? Equal the present value of the cash flow minus the initial. Present value of the cash flow, this is the cash flow divided by 1 plus R power T, summation of those. Okay? If we are not sure about the future cash flow, what you have to do? We have, as I mentioned, two approaches. One of them, if you have a risk, you have to increase the R, which is the WACC, the required rate of return. So the first one, we have to increase R. This is what we call it risk-adjusted rate of return. Risk-adjusted discount rate. Okay? Second one, we can evaluate, and in this case, we have to decrease the value of the cash flow. This is what they call it certainty equivalent method. Certainty equivalent method. So you have to recognize that the two approaches we are going to use, we have to use one of them. First one, by increasing the discount rate. So the higher the risk, the higher the discount rate. Second one, by decreasing the cash flow. Okay? Okay, so we can take this example. We have two projects. The first project, it has a cash flow, but you have to recognize what? MBC company faced the problem of choosing between two investing projects. And the initial investment of both of them equal, H1 equal 4,000, the life 4 years, and the annually cash flow of them, okay, could be like this. You have to recognize what? Unfortunately, we have 4 cash flow, and the project has 4 years. But in reality, no. All those cash flow just for 1 year. Okay? So it could be 5, it could be 6, it could be 7, and the year is 4. No, don't worry, it has no problem. But you have to recognize that all of those cash flow for how long? Just 1 year. Okay. But we are not sure which one will be exist. Could be 2,000, 3, and this is the probability. So what we have to do? You have to calculate the expected value, القيمة المتوقعة. How can we calculate the expected value? By multiplying the probability multiplied by the cash flow. 2,000 multiplied 0.1, 3,000 multiplied 0.4, plus 3,600 multiplied 0.2, plus 3,400 multiplied 0.3. Summation of those, we'll call it expected value. And we have to do, okay, and this number will be for how long? Will be for 4 years. So it will be annuity. And the second one, we have to do the same, multiply each cash flow by probability to get the expected value, and this one for just 1 year for the whole period. This is what we did. So the first time, we have to calculate this one. Okay, so 2,000 multiplied 0.1, 3,000 multiplied 0.4, plus 3,600 multiplied 0.2, plus 3,400 multiplied 0.3, it gives us expected value equals 314. So this is the cash flow, but you have to recognize again this for how long? 1 year. But we are not sure which one will be exist. And this is the expected value. We can calculate the deviation, this one minus this one, give us the deviation, which is the difference. To calculate the variance, you have to square this value. So by squaring this value, we will get what? We will get the deviation squared, multiply the deviation by probability, we will get the variance. So this is the variance, okay? Just to remind you, variance equal what? Variance, which is sigma squared, equal the summation of the deviation between R minus R bar. To avoid the negative and the positive value, it would be what? Squared. Okay. This is divided by n. If we have a probability, instead of divided by n, you have to multiply by probability. So this is the equation of calculating variance. To get the standard deviation, you have to get this value under the root. So sigma is the square root of what? Of variance. Okay, this is what we did exactly. This is why this is the cash flow, this is the expected value, which is the mean. This is the deviation, the squares of the deviation, probability, multiply deviation by probability, you will get that. This is the variance. To get the standard deviation, you have to get the root of this one. So this is what? This is the standard deviation. We have the coefficient factor, معامل الاختلاف. Okay, معامل الاختلاف أو coefficient deviation. معامل الاختلاف equals the standard deviation divided by expected value. So it is equal 0.14. Why we need this one? Because sometimes they said the risk project must be evaluated by a higher expected, higher discount rate. And the lower risk project must be evaluated or discounted by lower discount rate. So you have to know how can I recognize which one is more risky. Okay? طيب. Second project, I calculate the expected value, which equals this value multiplied the probability, and this is the expected value. Deviation, cash flow minus expected value, this is the deviation. deviation squared, this is the probability, by multiply this one by probability, this is the total value of variance. We have to get the root of this one. The root of this one, we call it the standard deviation. The deviation coefficient or coefficient factor, standard معامل الاختلاف, standard deviation divided by expected value. This is 0.53. Now, we recognize that project B is more risky than project A. So, if I give you two discount rate, one equal 15 and one equal 10, and I said use the higher discount rate for the risky project, the more risky project, and use the lower discount rate for the lower risk project. So in this case, you will use 15% for the second one and 10% for the first one. But in our example, he used another measure for the discount rate. He said what? He said, if we go back to the example, he said what? The company decided to adjust the cost of capital, which is 9%. This is the cost of capital for the whole company. Before, there is no difference between the cost of capital for the company and the cost of capital for the project. There is no difference. But now, because each project has a different risk than the company a whole, so in this case, we can use a different discount rate for each project. So, this is the discount rate for the whole company, not for the project. So this is the cost of capital for the company, not for the project. And what they said? They said that the risk-free rate equal 4%, and they use beta for the project 8 as a measure of risk. So beta for project 1 equal 1.6, and beta for the project B equal 0.4. So in this case, we need to calculate the discount rate for each project. Remember, the equation we used before when we calculate the cost of common stocks, when we calculate the cost of WACC, it is the same idea. Here, this is the cost of the project, and we do the same. Okay? This is the cost of the company. Sorry, cost. This is the risk adjusted discount rate for project 1 equal RF, same idea, plus risk factor or risk index for project 1 multiply the cost of capital or the WACC of the company minus RF. By number, it will be, this is 4% plus 1.6 multiplied by 9% minus 4%. So 9 minus 4 is 5. 5 multiplied 1.6. This is 8%. 8% plus 4%. So the discount rate for project 1, according to the type of risk it has, it will be how much? 12%. I will do the same for project 2. Again, project 2, risk adjusted discount rate for project 2 equal 4% plus 0.4 multiply 0.9 minus 0.4, 5 multiply 0.2, this is 2%, plus 4% equal 6%. What does this mean? It means when I calculate the NBV for project 1, I have to use 12% as a discount rate. But for project 2, I have to use only how much? 6%. As for. Now, this is the project A. Don't forget, when we calculate the expected value, this is for only 1 year. And the project life is 4 years, so it will be 3,140 for 4 years, which is annuity. Multiply the annuity equation, 1 minus 1 divided by 1 plus 0.12. From where I got 0.12? From this one, we're using this equation. Divided by power 4, divided by 0.12 or 12%. All minus 4,000, which is initial. This gives me 9,537 minus 4,000, so it gives me plus 5,537. If I evaluated this only project, I will accept because it has a positive value, even if it has a very high risk. It doesn't matter. For project 2, I will do the same, but instead of using 12%, for sure I will use the expected value, but instead of using 12%, I will use how much? I will use 6% because it has a risk factor equal how much? 0.4. Okay, so this equation gave me 12,474 minus 4,000, so it will be 8,474. So in this case, regardless which one is more risky than other, I have to compare only between the net present value and choose the higher NBV. So in this case, I will invest in this one, which has a higher NBV. This is the method which we call it risk adjusted discount rate. طريقة تعديل سعر الخصم. We have another approach, don't forget. The second approach, we have to adopt the cash flow itself. Okay. This is, we call it certainty equivalent method, or sometimes we call it certainty equivalent coefficient. Okay. For this one, we are evaluating 2 projects. And each one, there is no probability. Please and be very careful. Here there is no probability, we have years. Which means this project is going to generate this value in first year, and this value in second year, and this value in the fourth year, in the third year. But in reality, we are not sure. We are not sure. So, if we are not sure, even the second project also are not sure about this one. We need to make it sure. How can we make it sure? Okay, to get the idea, if I asked you to compare between 2 situations, to get $500, but we are not certain to take this value or not, this is an expected value. You can take it, or more, or lower, or 500, but we are not sure. Or we can give you $300 sure. So which one you can use? It depends on your personality. You can take risk to take 500 or more or lower than 500. And another one, he can choose the 300 but with a certain. In this case, if we need to calculate the certainty equivalent coefficient. Certainty equivalent coefficient equal what? Equal the certain value divided by expected value. Certain value in our example 300 divided by expected value in our example 500. So the certainty equivalent coefficient, in this case it will be 0.6. Okay? So if this value is this value and expected value and not certain, to transfer it to put a certain value, it must be multiplied by a certainty equivalent coefficient. And it could be calculated like this one. طيب, what he said? He said that the certainty equivalent coefficient, it could be for project A, year 1, 0.8, year 2, 0.7, year 3, 0.5. But the coefficient of certainty for project B, 0.9, 0.8, 0.6. So what I have to do? In this case, so easy. I have to transfer the expected cash flow for each project to be certain cash flow. So this is the expected value for each project, project 1, by multiply by certain equivalent coefficient. Sorry, we'll change this one to be coefficient. For project A, 0.8, 0.7, 0.5, this multiplies, this give me this value. This multiply, this one give me this value. 1058 multiply 0.5 give me this value. You have to know that this value is now a certain value, which means it has no risk. So we have to do the same for the project 2. This is the expected cash flow, project 2, multiply certain equivalent coefficient, this one. So it gives me a certain value. What I have to do now? I have to calculate the NBV. NBV, I will take, please, I will concentrate. I will take the certain value, and because this certain value is a certain now, has no doubt. So in this case, when I discounted this value to calculate the present value, it has to be discounted by the risk-free rate, not by the WACC or any discount rate. Must be discounted by what? By risk-free rate. So I have to take this value divided by 1 plus 5% power 1. This value divided by 1 plus 5% power 2. This by 3. This is what? This is the present value of the certain cash flow minus the initial, give me the net present value. NBV for project 2 equal the same certain cash flow divided by 1 plus RF. Don't forget RF. Power 1, power 2, power 3. Give me what? Give me the present value of the certain cash flow minus the initial, give me the NBV. Now, I have to choose between which one has a higher NBV. Okay, both they are a positive NBV, so I can accept both if I have no problem. But because he said we need only one, so I have to choose the higher NBV. Is it okay? Again. Now, the conclusion. If you are going to evaluate the project under uncertainty, under risk, we have two approaches. First approach, is the risk-adjusted discount rate. In this case, what you have to do, you have to recognize which one is more risky. And the risky one, you have to discount its cash flow by higher discount rate. And the one with a lower discount, with a lower risk, must be evaluated or discounted by lower discount rate. So, according, for the exam purpose, we can give you two discount rates. One of them is higher and one of them is lower. In this case, you have to calculate the variance and the standard deviation, and the higher variance or the higher standard deviation must be evaluated by higher risk, higher discount rate. And the one with a lower standard deviation must be evaluated with a lower discount rate. This is one method. Second method, what you have to do if you have uncertainty, you have to transfer the uncertain cash flow to be certain by multiplying the uncertain discount flow, cash flow, by the certain equivalent coefficient to transfer it to be a certain value. Use this certain value to calculate the present value of the cash flow by dividing or by discounting them using the risk-free rate. In this case, you will get the present value of the cash flow, deduct the initial. In this case, you will get what? You will get the NPV. Okay? See you inshallah.